wants one, just take one. It's just a PowerPoint of what I put together. As Ryan said, I work for the Natural Resource Conservation Service out of Jamestown, North Dakota. I cover southeastern North Dakota, multiple counties. I don't think I cover you guys, but otherwise, most of you in here I do, so. Figure out what we got. Yeah, my power wasn't plugged in. Now it'll be in 2016, this year, for our cost share program EQIP, the Environmental Quality Incentive Program, North Dakota NRCS did decide to adopt variable rate irrigation as a practice that we were willing to work with. Prior years we hadn't, so this is the first year. We haven't processed all of our applications. We're busy working on that right now, and I'll go through all of that once I get up and rolling again. As far as I'm aware, there's only a few states in the United States that is doing cost share. NRCS is doing cost share for variable rate irrigation, so we are actually kind of one of the first. We've been borrowing some advice from some experts around the country, so we've had a few other people involved, which is good. So, basically what we have going on, Ryan kind of asked me to talk a little bit about what the program, what was available, all the nuts and bolts of it all. So we had a sign up last year, which you had to come in the door by October 12th, I believe, and sign up, and a couple of people in the room had done that, and we're working with them. For next year, if you're interested in what I end up talking about, you have to walk into the local county office by May 1st is the whole thing. So you need to come in by May 1st and express interest for cost share or technical assistance from us. We'll provide both to you. Then what we'll do is we'll spend all of summer and fall working with you and all our other applicants on a plan to come up with what we think would be a good, what we think we can provide technical and financial assistance for. Then we'll rank your application versus everybody else in the state, and that has to be done by October. So the timing on this will work better for us to gather some field data, because this year I had to gather field data in November and December, which was kind of a challenge. I couldn't quite get, all the stuff I wanted, I'm still kind of struggling with some of it, so that was a little bit of a challenge. So this next year should be better. So once we get through this, if you're interested in it, make sure you walk in the county office by May 1st. So EQIP. Basically, we want to make sure, there's a few things when we're providing financial and technical assistance, we want to make sure that there's a conservation benefit that's, we want to look for water savings, we're going to look for some wildlife benefits, some erosion reduction, soil quality, and energy savings. So those are kind of some of the big things that we're trying to achieve with our cost share. In order to qualify, you'll have to have irrigated 2 out of the last 5 years on that piece of ground. So if you're just putting up, we won't do anything new, and that because we want to try to work with what we have. So you have to have the irrigation history. We're not going to help you with any maintenance that you might have in your system, so that's going to be up to you guys. And like I said, we're not going to start on new land, so we're only going to work with what's already out there. Okay. One of the things that we have been doing since 2004 in North Dakota is we have been doing conversions from high pressure to low pressure, and I've worked with some of you guys on that. Worked with Ryan quite a bit on quite a few of these. That's where we were taking high impact sprinklers on the top, and then we put drops with new sprinklers and regulators on them. We'd also would look at your pump to see if it needed to be, trimmed, the impeller's trimmed or anything, just in case, to make it operate in a better range if your pressure's changed. And if your supply line had any issues, we would have looked at your supply line also. So those are the things that we have been doing and we will still do in addition to variable rate. We also do conversions from flood pivot to flood to pivot, but I don't have a lot of that in this part of the state. But that's another thing that we work on in North Dakota. Aaron obviously has talked quite a bit about variable rate, and one of the things that we decided in North Dakota when we decided to work on variable rate was that we didn't want to just do speed control, and Aaron touched on that quite a bit. I mean, our goal is to see you improve water quality is one of those big things. We're seeing a lot of people that walk in the door that have wetlands and areas that they can't see, that they're not farming, that they don't want to put extra water on. And we see that as a real benefit. But we also want to go all the way and make sure that you're doing a full VRI on it, not just speed control. So that's one of those things that we wanted to make sure we distinguished. We also tried to make a threshold of what we were concerned in the field, like what percentage. We didn't want to spend a whole lot of financial and technical assistance on fields that only had a small little percentage that needed to be treated. So we set a threshold of 10% of the field had to have soil conditions, topography, or non-farmed areas, wet areas, in that, under that pivot that we wanted to achieve. So I looked at, yeah, go ahead.
With that, we're in the western part of Stutzman where we have pothole regions, but there are also some high sand berms. Is that going to qualify as part of that?
Yep. Soil change, essentially, yep.
Right, it can be gumbo, it can be bowl sand.
Yep. And I'll show you, well, if I can, I'll show you a couple examples of what we looked at. I mean, ultimately, that's a scenario that we want to help you with. We want you to be able to apply that water in a much better rate, and hopefully in the end you can also make it a little more energy efficient too. So for us, we're seeing it as a benefit of water efficiency and energy efficiency in that case. And we'll take into account soils, we'll take into account topography.
Well, we're looking at, we can gate and fertilizer through there. I'm not throwing in the water, not wasting.
Exactly.
I can cut savings $100 an acre on 30 acres. That's a lot.
Yep, and we see the benefit of when you're chemigating or fertigating, that you're not putting that in an area that, from a water quality standpoint, we want to see that too. So, yeah, I would definitely one of those cases that we can look at. We had, in our short little window, we had 50 to 60 pivots that were interested in this in the southeastern part of the state, and in the end we narrowed it down because we only had so much funding. And so I've been working on 26 pivots right now, and we were looking at all of those things, layering and taking a look at, okay, how much does this field need it, and how much of the field needs it, that type of thing. So as for the items that that are available for financial assistance from us, it's a lot of the stuff that Aaron had talked about, basically the valve control on the pivot. So this portion of it, definitely. We're looking at paying that as a linear foot. So if we go through all this process and we decide you need it for 700 feet on the pivot, we would pay for 700 feet. If you feel, and your dealer and your agronomist, whoever you're working with, feel you want it for the whole thing, we're still only gonna pay for probably like 700 feet, or work on negotiating what that distance is gonna be. So we'll pay for that on a footage basis, but in that footage payment, we've already accounted for the GPS component, the panel control, all the things you need, the nodes, all the wiring, all of that is kind of built into that per foot payment, okay?
The per foot thing could be a little bit tricky, just at variable spacing as well.
Yep. And I think we're willing to work a little bit on that amount that you would do. We just need a basis on what we're gonna pay for at this point, I guess. And this was 16, I will say, it may change for 17 for next year. This was just based on what we'd spent all this time on, so. So that is gonna be part of the thing we'll pay for. The other thing is if you need a VFD, if we go through and look and see if your pump, if you're gonna shut off and you're only gonna have 300 gallons a minute, and your pump doesn't do very well, you may wanna install a VFD, that's something we can help with. So we will look at that as a cost share component, and that's just a flat rate. Happens to be like $8,400 right now towards that amount. you know, NRCS's goal isn't to pay for all of it, we'll pay for a portion of it. I think they shoot for like 50 to 60%, so.
I have a question.
Yeah, you bet.
This is the best product I've seen in 20 years. I know it takes time for you to get applications through. If we move forward and sell an application, can we still qualify, or do you gotta wait till you give us the green light?
You have to wait, so you have to work with us on, we determine if we think you're eligible, then we see if you can get funding, because you compete with people all over the state. And then after that, we'll get a package like from Ryan, review it, make sure it makes sense. We'll give you the green light, and then you go ahead and you install it. It may take a year, so it's not like it's quick, but yep. So if you walk in the door in May, we won't find out till next October that you're funded. You probably wouldn't put it in till a year from now.
For 17.
Yeah, yep, that's how it's gonna work.
But you don't know how much your money you're gonna even have to do any funding.
Nope.
So there's a lot of question marks here.
Yo, lots, yep. Wish I knew more, but you know, we know what we're getting for this current year that we're processing, but we have no idea for next year. You know, it's all based on Congress's budget, so. And each state gets a different amount of money, and then within the state, we get to decide how it's spent. And we have a dedicated funding pool just for irrigation that we compete against the state, so.
So you know what you have for this year. Is there a
Yep.
goal date that you have that you're gonna have it determined as to who gets what approvals?
2 weeks, yep.
I might have missed that.
Nope, that's all right. We had to have all our rankings in tomorrow, so I had to have all cost estimates and estimates on what we're gonna do for each one of these applications by tomorrow. And then it'll take about 2 weeks to figure out who gets funded, and then we'll write our contracts, you know, set up what the legal part of it in the next 6 weeks, 8 weeks. So probably by like the end of March, we'll be ready for them to purchase things essentially. But we'll also have to, from an engineering standpoint, I have to go through and make sure the designs all work and stuff, so. So I've got a little work ahead of me, but, so yeah.
What is the average percentage?
Basically what we're gonna do is we'll list each component that we're gonna pay for, and I have a rate on it, but they shoot for when they're developing the rates to be 50 to 60% of what we think the cost is. Now I haven't had the time to go through and figure out roughly what it is. I mean, I've seen some packages, and you can ask Ryan what it'll cost you, and then we'll tell you what we can provide to you, I guess. So VRI, obviously on the system, a VFD if you need it. We're gonna require a couple other things in addition to that, and one will be to put a flow meter in that works, so that you can monitor the flow that's going through the system. We'll cost share that, and like a flow meter on an 8-inch pipe is $2,300. We're also gonna require that you have an irrigation water management plan, and we'll work with you on that. And that's a 3-year contract, and what the irrigation water management plan is just that we help you decide how to use that prescription correctly. And then we want you to install soil moisture meters with that, so that you can use the information on what the percentage of the water is in the soil, so that you can determine when to water essentially.
Is that the checkbook system yet, or if you?
This would be more, so there's, yep, and I was gonna go through that, but we've got 3 different levels of irrigation water management. What we call the basic plan was just when you're using the field method and kind of the checkbook method to determine your irrigation water management. And then we have an intermediate, and then we also have an advanced. When we're doing VRI, we're gonna want you to do advanced and utilize all the technology that's out there. So the advanced system, we're gonna have you put in soil moisture meters that have telemetry, basically that they can talk with your panel, and talk with a cell phone or a computer, so that you can make those decisions quickly, essentially. So it's a little bit more than just the checkbook method.
You're gonna pay a percentage, not?
Yeah, we're gonna
10% of that?
pay a flat rate for that irrigation
Okay.
water management, and we're gonna require you to do it for 3 years. And then we would sit down with you at the end of each season and talk about, all right, well, how did season 1 go? Did you follow your plan? Do you want to tweak it for next year? That type of thing. So that's what that would entail when you're working with us, is the moisture meters and the technology to do it.
Is there any requirements in regards to the brand of flow meters or probes?
Nope, not at all. And I'd asked Ryan that when we were at lunch. I just said, hey, do you have soil moisture meters available through you guys, and you do. A lot of times I think that's, you know, if you're trusting of it, that's probably your best bet. We were hoping to also, when we work with you, to come up with a list of others available in case you were just looking to see on the market what's out there. There's a wide variety. So there's a few choices. We were just trying to look for some local ones, like within North Dakota, South Dakota, Minnesota, that you would be able to use. So that's something we hope to provide to you if you're gonna work with us too. So trying to make it a little bit easier if we can. So that's the goal. But so obviously if you work with us, there's gonna be a few other things we wanna see. So that's what I wanted to cover with you. We also we're gonna do a little analysis on your system to make sure that your pivot is functioning and up to our standards, and that your pump is, and your supply line. Erin did a really nice job of covering that it's important that your pivot is working and functioning very well before you put VRI on. One of the things we're concerned about is the uniformity coefficient, how well your water is being applied through each one of your nozzles. There's some data out there that says that it's really important that you have good uniformity on your nozzles before you put VRI on.
So if you come out and my nozzle package is trashed, you're gonna say, hey.
I'm going to tell you to replace it, but I will provide a cost share to do it.
Really?
Yep.
It's more than fair.
So that's the other thing about this. If you're missing one little component that things aren't up to our standard, then we will hopefully provide some cost share for you. From what I can tell, that'll happen if it's a big thing. Now, if you're just missing an air relief valve, I can't just pay for an air relief valve, but I could pay for the pipeline if it needs to be replaced. So there's a few little things that you may have to do out of your pocket, but overall, if it's a big item, we should be able to provide cost share for you.
Even with the complete system?
No, we will not do the whole
That's
pivot.
I mean, pumps, pipeline,
Pumps,
pivot.
pipeline, VFD, the drop nozzles, the pivot itself, we'll never touch
Okay.
that. That will be out of your pocket. You know, if you get to the point where you have an old system and you want to do VRI, but maybe in the end you're thinking you should replace the pivot, we'll determine if the nozzles needed replacing, and we may do that, but that's about as far as we would go on that. You'd have to pay for the pivot.
How about rental property? Somebody that owns a
Yep,
solid state.
good question.
Should they apply for that?
Yeah, so typically we want to work with the renter on this.
Right.
You may have an agreement with the owner of the land on how you're going to do all that, but we need an owner certification that it's okay for you as the renter to go ahead and install this practice and manage it properly.
Have a 3-year contract, I would assume.
Absolutely, yep, it'd be for the life of our contract, and our contract then is actually 4 years. We have 1 year of maintenance at the end. So you'd have a 4-year contract with us.
So I'm fair to my landowner, what if I'm dead or gone or whatever, did they gotta pay the money back then?
I'm not the contracting person, I'm the engineer, and there's some things that happen there. I believe nobody, that if it's not their fault, it's not gonna be,
They're not off.
yeah, I believe, like I said, that's
It
not.
used to be they have to pay it back.
If it's been installed and it's done, I think what we do is just, I believe, is terminate it, and then we probably wouldn't do like irrigation water management. So if you got VRI done, and you had 1 year of irrigation water management, and then something happened,
Right.
I suspect that's what we would do. So, yeah. Again, that's not my forte. So basically, again, we'd come out and we'd work with you on, I want to come to the field, meet you, look at your system, and I'll gather all this data, and then we do kind of an analysis to figure it out. I had an example map in here, and it's a lot like what Erin was showing. We just had a few exclusion areas where, like, say, the end of the pivot, we wanted to shut off towers, say, 4 to 7, and we were going to pay VRI on that part of it. So that's kind of what we're making that determination. We're not going to tell you how many nozzles to shut off and what your prescription is going to look like. We want you to work with the people that Erin listed, you know, whether it's your agronomist, your dealer, whoever. I'm not going to dictate any of that, but we also need to figure out what's applicable for us to pay for. So taking a look at, you know, what the flow rates are and how it affects the pumps and stuff like that too. So it's new for us, so I think we're putting a lot of work into these up front. I'm hoping a couple years down the road, maybe we've got a pretty good feel for some of this and we won't have quite as much work, but it's taken a little while. So as I said, we see a real benefit in the energy savings, the water savings, and hopefully improving some water quality, so that's what we're looking for. So we're gonna go through, we're gonna calculate, you know, how much water is saved, what's being shut off, and how much energy we're saving on horsepower on a pump when you're only operating a portion of it, so. I guess the rest of my presentation was kind of to cover the irrigation water management stuff that we'd already asked. So essentially, again, we'll want you to practice advanced irrigation water management and put in these good moisture meters and use them. There's, like I said, lots of choices, and we'll try to help you with some of the choices on what those would be.
Erica,
Yeah,
a moisture meter, let's just say you put one in a designated area, or say the.
Yep.
I guess how much area you can put in?
so I think we were trying to decide this a little bit too, because again, it was, in North Dakota, it was kind of up to some interpretation as to what we wanted to do. But we felt like once we figured out how much you were gonna shut off and what your exclusion areas are, you're still gonna have a portion left that you wanna manage. And I think you'd probably look at your soils that are out there, your topography. We'd probably wanna see at least 2 in a field, if not more. And we're just gonna actually pay a flat rate for the field itself. So if we kind of sit down with you and decide you need 4, but your neighbor may only need 2, it's just gonna depend on what that field is specific, what you're trying to manage it for. So,
Aren't you gonna have, where I'm at, aren't we gonna have to lean to the higher side of the field? You know, on soybeans or pinto beans, you let the highest part suffer until you kind of win the water the field for the rest of it.
yeah, I think that would
That's our majority.
probably be part of it. Yep.
Right, but this is different, because now we can water less in the
I
lower
know.
ground. I mean, this has real savings written all over it.
Right, and that's why, it'll be a pretty big change in how you operate your system,
Yeah.
and that's why we wanted to do the irrigation water management part with you too, is because you've operated that system trying to do as much as you can at one point, and then once you add VRI, you have a lot more capabilities, and that's kind of what we're hoping to do with the irrigation water management, is help you change your thinking a little bit on how you're gonna water that system, or camigate or fertigate too.
Well, our kind of ground, when you got enough for the high ground, or your low ground turned into crap because of white mold and what have you, I mean, it's
Yeah.
been a rough go.
Right? So hopefully you can manage that a little better, yeah.
In my mind, just hearing what you're saying there, and maybe I'm all wet, but you kind of want to probe in your high soils for one, as well as
As
your
you-
bottoms, so that
right.
you make
So
sure
you
you're,
have a-
everything else is in between,
Right,
and
so
you
you
work
have
with
a
that.
good idea
Yep.
of the whole picture.
Right.
Good.
So we're not experts by any means. Like I said, this is our first year, and we're trying to decide what all information we need, and but we do have some technical assistance, some financial assistance out there if you're interested. So I think that's kind of what. Is there anything else you wanted me to cover, Ryan?
No, that covers everything.
So walk into your local office, and if you're in my area, you may end up seeing me because I'm doing all the VRI stuff. So, and my contact information is on the last page. If you want to call me directly, that's fine too. I'll answer your questions. So. Thanks, guys.
A couple quick things to go over here as far as applications go. Install a variable rate system. Pumping system considerations are the biggest thing when you install a variable rate system. And I just have a couple examples to go over. So pumping system considerations. Will variable rate increase my pressure dramatically? That's the biggest question, and yes and no. It's a matter of what kind of system you have, what kind of pump you have. You look at your pump curve. How big, or what does your pump curve look like? Excuse me. Is it a flat curve? Is it a steep curve? I'll get to that in a second. The number of pumps that you have. Is it possible to cycle some of them off to reduce your pressure? And how much of the system are you controlling? Are you controlling the whole machine, a couple spans? I mean, what's the variation going to be? And that's what you need to figure out before you get to that point. So here's just a simple example, pump curve. This happens to be a submersible pump. I have 2 examples here. They're basically the exact same setup, 800 gallons per minute, which is typical for a machine. And we're going to say 45 pounds of pressure per pivot point. Pretty standard stuff. So, like in this case, 800 gallons a minute, we're at 160 feet. Now that's a unit of measurement, you divide it by 2.31, and that gives you your pressure. But for our purposes, we're going to say it's 45 pounds at the pivot point. So in this case, you go from 800 gallons a minute down to 400. Your feet go up by 25 feet. Well, simple math, 2.31 divided by 10 pounds of pressure. So you cut your flow in half, your pressure is going to go up 10 pounds. Now, is that a dramatic increase? No. You're going to go from 45 to 55. In a perfect world, you would put a VFD on there and keep that 10 pounds of pressure down. But VFDs cost money. We're obviously aware of that. So would this be a must situation? Probably not. You know, you have 10 pounds of pressure fluctuation. That's not a big deal. This one happens to be a submersible pump. Does not have a distinction between a submersible and a turbine pump as far as pressure-wise. This next one I have, it happens to be a turbine pump. And this one, same situation here. We're at 800 gallons a minute, and we're at 188 feet. We go down to 400 gallons a minute, and we're at 272 feet. 84 feet of difference divided by 2.31 equals 36 pounds. So, two identical pivots, identical setups, and our pressure goes up 36 pounds instead of 10 pounds. Just the difference in the pump. So in this case, you had 45 here, now you're at 81 pounds. Huge difference. So you don't want to be, you're almost twice the pressure you need to be. So in this case, you would be in the area of putting a VFD in there to slow the thing down, because that's you're expending the electricity for all that extra horsepower to make all that pressure, and you don't need it. So again, this one happens to be a turbine. Doesn't really matter, submersible turbine, but same thing applies. I know in some cases, a guy might say, well, if it's a turbine, why don't we just, like this here is a 4-stage, can we just knock one stage off of it, drop the pressure? In some cases, maybe, if the curve is flatter, but in like this case here, if you do that, you knock a stage off of there, you're going to lose about, let's just say 20 pounds, then you're going to be wrong on both ends. You're going to have 25 pounds in your pivot point, and you're going to have 65 on the high side, so you're still wrong. So that really points to having a VFD to get your optimum pressure all the time. So that's the main point of that example. Question would arise, well, if I don't have a pump curve, I don't know what's down the hole. That's very common. I know whenever we pull a pump out, we get a pump curve, we put it in a file, but there's a lot of pivots, we don't know what's down there. We have changed, so it's actually a pretty common occurrence. So you can do a simple pressure test. Simple control valve, flow meter, pressure gauge. Do it at your pivot point. You can reduce your flow and see what the pressure does. I mean, pretty simple. Crank the valve down, 800 gallons a minute, 700, 600, see what the pressure does. If you drop down a couple hundred gallons and it goes up 30 pounds, then you pretty much know where you're going to be. That your pump has a really steep curve. If you choke it down and it only goes up 10 pounds, well, then you got a flat curve, then you're in pretty good shape. So something like that, it's a very simple thing to do, a lot cheaper than having to pull the pump out, analyze it, and see if it's going to work or not. So very simple thing to do. Again, flow meter, we have flow meters, control valves that we can let you use. Just do the test and see. The number of pumps is kind of another thing. On multiple pumping systems, you have multiple pumps. Sometimes a simple pressure switch can drop your pressure down. Now, I'm saying in a case where you have 5, 6, 7 wells, when your pressure goes up, you can just put a simple pressure switch on one of them and turn that pump off. So your pressure spikes, it turns off a pump, it turns off another one. When it drops, it turns it back on. Simple setup to do that. So again, and all that kind of ties into the design of the variable rate system, which we know when it's made what that flow range is going to be. You know, what the minimum, what the maximum is going to be. So right away you can say, okay, my system, my variable rate system is going to go down to 400 gallons a minute. you can look and see what's gonna happen when that occurs. And again, you should do it beforehand. And then, optimum choice obviously is a variable frequency drive. Excuse me. Just like cruise control is the best way to put it. You set a pressure, and it just maintains that pressure all the time, no matter what the system's doing. This one here actually, excuse me, has a rotophase on it. That's just, it's a phase conversion panel. This one is it's converting single phase to three phase for the pump, and single phase to three phase for the pivot. This doesn't have to have a rotophase on it. That's just if you need to control both. So, example. Standard quarter mile machine, 800 gallons a minute. High water table has some low spots in it, a couple wells. Basically, that's what it looks like, or what it looked like. You can see these areas here. These are all low spots, just kind of speckled throughout there where, again, they're wet every year, but you have no way to control the system, so they keep getting watered all year long, so you just can't get ahead of them. So what we did was, this was kind of the plan we put up, broke it up into some zones, which are pretty much, I guess, the same as the zones we looked at here. We applied it that way. In this particular example, it had two pumps, one here, one here. These had the flat curve like we talked about. This system was nozzled for 800. When we took it down to 400, the pressure only went up about 10 pounds. So this was one of the cases we didn't have to change it, didn't quite need the VFD for it, and ran it that way. So after, the results, you see something like this. You don't have that speckled area that we saw previously. You still have a couple spots here that didn't quite get planted, but again, a very improvement compared to what had happened previously. Second example, this one was a bigger machine, 2,400 feet, 1,800 gallons a minute, large area, almost a full section field, but some large lowland areas that were always wet, became troublesome spots for getting stuck in, but they continue getting water every year because there's no way to turn them off. So, and also multiple well system. On this one we put, this is how it looked before. As you can see, these are large areas that are, again, that are all green because they're water, but there's no crop there. That's just grass, cattails, stuff like that. And there was issues for getting stuck in this area and these various areas here. So we put together this kind of a basic plan here. This one was more so avoiding these low areas, where we turned the sprinklers off in these sections here. The sprinklers turned off gradually going into the sections, so you had you didn't have dry crop on the edges of it, but you avoided having the water issues in there. So I guess one of the other issues, or I guess one of the other points of this one was wells. This happened to have multiple wells on the system. I believe there was 6 wells here. I think 1 there, 2, 3, and there was 3 of them down in this low area here. So basically, on this particular setup, there was the electrician installed a simple pressure switch system on these 3 wells down here. They put in a little PLC computer that monitored the pressure switches, or the pressures. So as the pressure started to go up, it would start kicking off these pumps here, 1, 2, 3. Without that, the pressure was going up to 100 pounds, which was way beyond the point of safety. So we obviously had to do that. And again, 6 pumps, so we didn't have pump curves, so we didn't know until we did the test, and then obviously the pressure was too high. So this would be the example of using a pressure switch shut-off system. What else here? Then, so results. Here's the yield map before we did it. Again, you can see these white spots. There's no crop here in any of these. This was all just cattails. these areas we talked about, the total acreage of all these areas is about 40 acres. Again, it's a large field, so it's magnified a lot more, but we're talking 40 acres of land here that was not getting planted, was not into production, so. So this area is, again, before picture, after picture, it looks like that. I mean, we're talking.
Is that this year's map?
That was this year's map, yep.
And you guys had a wet year, correct?
No, not really. It's kind of a dry year, I guess. So, again, we're talking these big areas up here. This was all cropped. Straight east of the pivot point, there's a big dugout here, and none of this was planted. You can see now, there's the dugout. The dugout's dried out completely, and all this is planted around here. And where those wells were down here, all this is planted. So, 40 acres is what was missed before. We didn't get this over here, obviously, because this was a deep slough that it was just driving through. But so in the end, about roughly 35 more acres was picked up in these areas because it wasn't dumping water there when it didn't need it. So again, it's a bigger field, it's a section field, so it kind of magnifies the results. But again, pick up 35 acres, minimal investment, land that was already yours in the first place, but now you can put it back into production. So that's a pretty good example about what the capability of it can do. So I guess secondly would be kind of a bonus to it as well, is not applying water to these areas also frees up some more water that you could use elsewhere. In this case, some more water was put over here on a secondary pivot that wasn't able to be put there before. Go back here. It wasn't a pivot here before, and by freeing up the gallons here that weren't used, they were able to put another pivot up here. You can't really see it that well, but it picked up another 50 acres up here. So basically, the variable rate system allows you to cut your horsepower requirements because you're turning these pumps off during the year. If you're picking up more acres, you're saving water to possibly use elsewhere. So it's really several advantages of doing it in that capacity. So, and there's the yield map again.
You
So-
forgot one thing. They were out there with jacks and blocks, jack that up in the mud because you broke a
There you go.
wheel off in the mud. You spent 2 days and fighting one another. And
Well, the other thing that I always forget about until today, honestly, you guys keep bringing it up, is that northwest part where you're not avoiding is water quality. What are we keeping out of the water stream
Absolutely.
system from
Yeah.
fertilizer chemicals?
Yeah, yeah.
And we don't value that enough.
Yeah, that's right. Yeah, there was this whole section over here, that was about 5 acres of water that was getting irrigated before, basically. There's really no reason, so that was all stopped as well. But yeah, the wheel tracks, that's an excellent point. I mean, not getting stuck there, not getting stuck here, getting stuck here, that's, I mean, time savings, headaches, so, yeah. There you go. Any questions? That's basically kind of from an application design standpoint what we look at, kind of some of the benefits we can see from it. Anything else from Aaron or from Erica or anything like that? Anything else, I guess? Thank you for coming. Appreciate it.